All right, so here we are taking a look at this practice exam number 2, and I want to make sure that I work through this whole question just to kind of be helpful. So a ball is dropped from a height of 20 meters onto a hard surface, and we want to prove that it takes 2 seconds to fall. Let's see what we got. We could say S is 1/2 AT squared plus UT. Now it's falling from rest. It falls 20. The acceleration is 10 due to gravity. T is unknown. And our starting speed is 0. So we end up getting 20 is 5t squared. 4 is t squared. And then when we isolate, we're going to get t equals 2 seconds. Now, as the ball falls, let's be really clear. This is displacement versus time. So we know that it starts off at 20 and that it hits the ground at 2. And it's going to bounce back up. So it'll hit 4. At 4 seconds, it'll hit 20. At 6 seconds, it'll hit the ground again. And then at 8, it'll bounce back up. Let's be clear, though. As it falls, it's actually going to fall in the shape of a parabola because this is the equation that describes it. Its displacement is S is 1/2 AT squared, which in this case is S is 5t squared. Just to be clear, at 1 second it's fallen from in 1 second it's actually going to fall 5 centimeters. And just to be clear, the way we want to set that up in the formula is if we put in 1 for time, it's actually fallen from 20 to 15, so we can put that right there. And then at 2 seconds it's 0, at 3 seconds it'll be here. So we get this nice parabolic shape as it falls. And that's how we go ahead and actually solve this problem here. So that's part B. And then for part C, it says show that the speed of the ball just before it hits the ground is 20 meters per second. So we have V is AT plus U. V is 10 times 2 plus 0, which is 20 meters per second. All right. Then for part C, the velocity as a function of time. Well, so let's be clear. We'll say downward is negative, so we actually end up here. All right, so we hit the ground like that at 2 seconds, but then suddenly we're bouncing upwards in the same direction. We hit the top. Yep. And then we fall again like this. And that's the idea. So we need our speed to suddenly turn around when we bounce and start going up again. Now it says identify 2 forces that act on the ball during its collision with the ground. So it hits the ground. We're going to have a reaction force going up and the weight force going down. Now, we will in fact get a reaction force, and these form third law pairs. So the first is the FG third law is the force of gravity of the ball pulling up on Earth. And the R reaction force third law is the floor feeling the reaction force of the ball. All right. This is a very long kind of question. It says calculate the value of the acceleration of the ball during collision. The collision time is 0.1 second. So let's be clear. V initial is negative 20. V final is 20 because it changes direction. So we say V is AT plus U. And actually I'll change this letter to U and this letter to V. So we'll say 20 is A times 0.1 plus negative 20. So A ends up being 400 meters per second squared. Now, if we want to know the mass or the force, 500 grams, that gets converted to 0.5 kilograms. So we end up getting F is ma, which is 0.5 times the acceleration that we got before. And this works out to 200 newtons worth of force. So that is our paper 2 problem for this exam.